Welcome to this course on unit processes in water and wastewater resources engineering. Water is life, and wastewater is an inevitable byproduct of human activity. The responsibility of engineers is to ensure that the water we consume is safe and that the wastewater we generate is properly treated before being released back into the environment. In this course, we will examine the physical, chemical, and biological operations and processes that form the backbone of modern water and wastewater treatment. We will focus on both the theoretical foundations and the practical applications of these unit processes. This first module introduces the basics: reactor engineering, equalization, flotation, and the removal of undesirable substances like iron, manganese, hardness, taste, and odor. Section 1: Theory of unit processes. Unit processes are the building blocks of treatment systems. They can be classified into three categories. Physical processes, such as sedimentation, filtration, and flotation, which rely on gravity or mechanical forces. Chemical processes, such as coagulation, disinfection, or water softening, which rely on reactions between chemicals and impurities. Biological processes, where microorganisms break down organic matter, as in activated sludge systems or stabilization ponds. The combination of these processes ensures that water is purified and wastewater is rendered safe for discharge. Section 2: Reactor engineering. At the heart of treatment processes is the reactor, the environment where reactions and transformations occur. Understanding reactor engineering helps us predict how water or wastewater will behave during treatment. The three main types of reactors are: completely mixed flow reactors, where incoming material instantly mixes with the contents, creating a uniform environment. Plug flow reactors, where material moves through the reactor in sequence, like a piston, with minimal backmixing. Disperse flow reactors, which fall between the two, with some mixing and some plug-like behavior. Engineers use these concepts to design tanks and systems that maximize contact between pollutants, treatment agents, and microorganisms. An important aspect of reactor engineering is mass transfer, the movement of substances such as oxygen, nutrients, and pollutants within the water. For biological processes, oxygen transfer is especially critical because microorganisms need oxygen to break down organic matter. Section 3: Equalization. Water and wastewater flow rates are never constant. Factories discharge in peaks, households use water at specific times, and stormwater introduces sudden loads. Equalization is the process of evening out these fluctuations. Engineers design equalization tanks to prevent sudden surges of pollutants, provide steady flow into treatment units, reduce the risk of overloading equipment. This ensures a more reliable and efficient operation downstream. Section 4: Flotation. Flotation is a physical process that removes suspended solids, oils, and greases by attaching them to air bubbles, which then rise to the surface and are skimmed off. The most common method is dissolved air flotation, where air is dissolved in water under pressure and then released at atmospheric pressure, forming tiny bubbles. This method is especially useful for removing light, buoyant particles that do not settle easily in sedimentation tanks. Section 5: Iron and manganese removal. Iron and manganese occur naturally in groundwater and can cause staining, bad taste, and operational problems in water supply systems. They are typically removed through oxidation and filtration, where chemicals like chlorine or potassium permanganate convert soluble iron and manganese into insoluble forms that can be filtered out. Aeration, which adds oxygen to achieve natural oxidation. The choice of method depends on the concentration of these metals and the characteristics of the water. Section 6: Water softening. Hard water contains high levels of calcium and magnesium. While not harmful to health, hardness causes scaling in pipes and reduces the efficiency of soap and detergents. Water softening methods include lime soda treatment, where lime and soda ash are added to precipitate calcium and magnesium. Ion exchange, where hard water ions are exchanged with sodium ions in a resin bed. Softening improves the quality of water for industrial, domestic, and commercial use. Section 7. Taste and odor removal. Taste and odor problems in water often arise from algae, decaying organic matter, or industrial pollution. Removal methods include activated carbon adsorption, where carbon granules trap organic compounds. Aeration, which strips volatile compounds. Chemical oxidation, using chlorine or ozone. These processes ensure that water is not only safe but also pleasant to consume. In this first module, we introduced the categories of unit processes in water and wastewater treatment, the fundamentals of reactor engineering, including flow types and oxygen transfer, key processes like equalization, flotation, iron and manganese removal, water softening, and taste and odor control. These processes form the first layer of treatment strategies, preparing us to explore biological systems and sludge management in Module 2.